Now we're moving to the thermal function. So the thermal is that we are using is the NTC, and it's not linear. So it's not digital either. The GPI opens are all digital. We can't detect something that's analog from them. We can't use it. We need analog to digital converter. But the one that we had did not work, so we had to do something about it. We got a capacitor that is 10 microfarads, and it has 2 volts a threshold. Um, the idea was to charge the capacitor and discharge it and find out when the pin is going to detect it's on and when it's going to detect it's off. Using the time between those two, um, we can like map it to the resistance of the NTC and figure out how much the temperature is. For that, this is the whole process in here, and we used this differential equation to find out the temperature of the room, and then we do that for like 100 times. We use it for 100 times, and then we find the average temperature to make it as accurate as possible. Here is the main function. It's where the program is going to start with. Going to the setup up there, and it will start with calling the thermal function to figure out the temperature that the room has. It will convert it to Fahrenheit. Opens the text files for the temperature here. We have Celsius and we have Fahrenheit. And writes inside of them and then closes the file. That would be it.
Hello. Today we are going to demonstrate our cloud computing project, which you can see here. We have a website, and with this website we control an electric circuit on a Raspberry Pi. So the Raspberry Pi has Python running on it, and that Python is constantly reading from files to determine its state. Okay, so its state controls the circuits, and we have simulated it so that we are running kind of a toy model of a house, right? So you can see from the organization of the website, we have a thermostat section, a lights section, and a home security section. The thermostat has a fan, which has an auto control setting, and it also outputs the current temperature of the house. The light section can control the house lights between on, off, and auto, which is a night light setting, and home security, which contains an alarm system, which has a motion sensor built in, which triggers the alarm, and outputs the status of our home security system. Right now we're just running it offline just to demonstrate it, and we have an audio recording I guess integration. You can press this button here on the website and it will record 20 seconds of audio. It will write to a file actually, and then the Python will call a script which records 20 seconds of audio. And then you can listen to the audio from here using the HTML audio element. Okay, so when we press one of these buttons, like we want it to turn the fan off, for instance, we can open up the file for a fan, and we can see that it says off. Next, if we wanted to turn the fan on, we would click on, and then we would open up the file for fan, and it would say on. Or if we wanted to change the temperature control setting for the fan to 40 degrees Celsius, we would click auto, and when we open up the fan, it says auto 40, which is parsed by the Python and allows it to determine which temperature to set the house to. So this website is coded in HTML, JavaScript, and PHP. The HTML supplies the graphics and all of the text and all of the buttons, all of the shapes. Everything is done by that. So except for when you press a button or you submit any sort of data. When you submit data to the website, it calls JavaScript, which then determines what to do after that. Usually it just calls PHP, which writes to the files itself. So we have the organization of our website in 4 different files, and you'll see why later. So here, I'm not going to walk through this exactly, but I'll note some things. We have multiple different forms. So this form is for the fan, and you can see that it has one button that says on. It has another button that says off here. And there's another form for the auto, and this one has a text area. This text area, like we saw on the front, allows you to put in a number, and that will be written to the file as well as the word auto, right? So we have this for lights, motion sensor, record audio, of course. Here's the audio element that's in HTML to play the audio that we record. And when we press a button, it calls JavaScript. So down here, we have the JavaScript element, which shows us that we're now in JavaScript. So HTML is over, JavaScript begins. So JavaScript is ready to do anything now that we have the document ready. So whenever we click one of the buttons, this .click method on the button object is called, and a function is done. So if we were to click the fan auto button, then our function would be to make a variable fan setting of the fan auto, which is the text area up above. So it'll take the words, the text from that setting, and it'll put it in this variable fan setting. Next, we trim the fan setting for any spaces, and we say if it is set, we will call another file called controls.php. We will use the post method, and we will give it the following data. Fan is set to auto, and fan setting is set to fan set, which we defined up here. So inside our control setting, we're going to say, since all of the buttons actually call the controls.php file, first it has to determine which button was pressed. So it could be the fan, it could be the light, it could be the alarm, or the microphone. Since it was the fan, it's going to run this. It's going to open f.txt. It's going to clear it. It's going to write the fan setting to it, the new fan status, I guess, which is either on, off, or auto. And if it's auto, then we'll also have our fan setting, which we wrote back in the last file. Our fan setting we will put in the file as well. Then we will close the file, right? And that's exactly how we put the data in a file. And after we press the button, the data will be read by our Python, and physical actions will be performed, like turning on the fan. So we have that. Next, I want to display this area here. So this area updates every 1 second. This area here and this area here. That gives the outputs of the different sensors around the circuit. So we have our security sensor and our current temperature. This is just an example. Of course, my home is not that cold. I'm just reading from these files here. And if I change some values in the files, so if I go into the security file and I change it to safe, and then I save the file, we can see that it updates on the website. Well, I think that's all I wanted to show you about the website. I'll just scroll through all of the different ways. If you're interested, we have our document, our paragraph element here with an ID security status, and this is updated later on in the program. We set an interval to call this function every 1,000 milliseconds, which is every 1 second. And then it loads our paragraph, which I just showed you upstairs. It loads it from temp status PHP, which is this file. And this file reads from the file, gets the string, closes the file, and if the file is not empty, it will put that in the element that we ask it to, right? And we asked it to put it in the temp status in this case. Temp status here, temp status, or security status, which is the same thing, but for the security. And this allows us to have dynamic forms using Ajax. And dynamic buttons, which can be pressed and don't trigger a page refresh. So we learned a lot from cloud computing class about some of the different methods, and we've learned a lot from this project about how to actually implement those methods. So this was our project. It was a distributed application in the smart home sector, which is almost an Internet of Things kind of thing, given that it has sensors and actuators and it's controlled from a distance and it logs data. So thank you for watching, and I guess I'll see you in class.